coming in the future. We want to thank our sponsor, Fierce Wireless, where industry insiders turn to find out what's going on in the wireless landscape every day. I take a look at it. I think business executives and carriers look at it every day to see what's happening on investment deals and network infrastructure evolution, wireless technology, mobile handsets, and more. I'm going to introduce the editor of Fierce Wireless, Phil Goldstein. He's a great guy. He's the day-to-day editor of the publication. He also copy edits Fierce Wireless Europe. He gets excited about the latest smartphone launch like other gadget geeks, but he's also an avid lover of the New York Yankees and poetry, in case you think those two go together. So without further ado, welcome Phil Goldstein.
How's everybody doing this morning? Great. So I'm going to introduce our panelists, and then I'm going to give a little introduction, and then we're going to start our discussion. So from right to left, we have Glenn Laxdal, who's the Vice President of Advanced Technology Solutions at Ericsson North America. Then we have Sungho Moon, who's the Senior Research Engineer for Wireless Communications at SK Telecom. And then we have Ken Sandfeld, who is the Executive Vice President of Solid. So my name is Phil Goldstein. As Jonathan said, I'm the editor of Fierce Wireless. We like to say we're the wireless industry's daily monitor. Hopefully many of you subscribe to our daily newsletter. If you don't, please do, because it's free. And the last few months in particular in Fierce Wireless, we've been covering more and more stories about 5G. Initially, and probably still to a certain extent, we have 5G in quotation marks because, as many of you probably know, there is no 5G standard. There are many groups that are starting to work toward a 5G standard, but it's nothing more than a lot of discussion at this point. So you have different groups from Metis 2020 in Europe to NYU Wireless to the 5GPP, who are all trying to grapple with some pretty fundamental and basic questions about 5G and about where the network evolution goes from here. And what we're going to do this morning is try to have a pretty robust and fulsome discussion on sort of three distinct pieces of this puzzle. First, we're going to try to get our arms around what is 5G and how do we define it and what is it going to enable. Then we're going to talk a little bit about how 5G may or may not change network design. And finally, most importantly for everybody in this room, we're going to try and talk about how 5G is going to directly impact the infrastructure industry and all of your businesses. We're going to try to leave about 5 to 10 minutes at the end for questions from the audience. So throughout the discussion, feel free to be thinking of your questions, and then we'll have a mic go around at the end of the discussion so that the audience members can ask their questions. So I'm going to start off asking the panel a pretty basic question, but one that obviously could have a multiplicity of answers, and we'll go down the row for this first question. So Glenn, we'll start with you. How, at this point in time, mid-2014, would you define 5G?
Great question, and great to be here. So thanks for the invitation. Thanks for the opportunity to speak. I think how we would define where 5G is right now is, as you had indicated, we're in the discussion phases, and probably more so than the two previous generations of wireless, 2G and 3G. We think 5G is going to be much more use case driven. And when you look at the timing of 5G in the 2020 timeframe, there's going to be a pretty tremendous deployment of 3G and 4G in that timeframe. 3G UMTS HSPA-based technologies and 4G LTE-based technologies, that those have to be accommodated when you think about 5G. So 5G would be additive as opposed to replacing those pre-existing technologies. Globally, we'll have almost 6 billion smartphones in the world by 2019, and about 3 billion of those will be LTE enabled smartphones with LTE coverage. So 3 billion LTE phones, 6 billion smartphones, 8 billion mobile broadband connections, and all of that is before we get to 5G. So when I say 5G is going to be use case driven, 5G is going to be adding on to the capabilities that we need to handle the use cases that we're unable to get at with the LTE and HSPA coverage. And so we think in terms of 5G being probably up spectrum, above 3 gigahertz, maybe even above 6 gigahertz. So in the millimeter wave, which is where you have a lot more bandwidth to play with. So 5G would be able to enable those use cases that require incredible bursts of bandwidth. We see it probably being low latency, meaning the ping time between the device or the machine and the network will be much lower than LTE, moving from say a 10 millisecond ping time to a 1 millisecond ping time, and we see it especially being utilized for the machine-to-machine type of use cases, which is the one use case that requires a lot of capabilities that aren't necessarily inherent in the existing air interfaces. It requires very low energy, very low latency, and the ability to connect literally tens of billions of devices, 50 billion or 100 billion devices to the network. So those are the unique challenges that 5G would be intended to implement. So just basically we see it as a layer on top of 3G and 4G, not replacing 3G and 4G, probably up spectrum, probably low latency, and probably driven more by the use cases than the previous air interfaces have been driven.
Sungho, do you want to add on to that?
First of all, I want to start with the introduction of the SKT. Probably you might know heard about SKT. SKT is one of the leading operator in LTE and LTA. So we have 50% of market share in Korea. And we started LTE in 2011, and 2012 we started multi-services and multi-carrier. And finally, last year we started LTA services with a carrier aggregation. So with this kind of the leadership in the commercialization, we also have done a lot of R&D activity for the advanced technology like TM9 or Telecom and TDD, FDD carrier aggregation. So recently we heard about 5G, and many people asked what is a 5G. So I agree that 5G definition is still ambiguous, and nobody can exactly define yet. But in an SKT perspective, I think we can say 3 major ways to 5G. The first thing is a super network. That means we can get more capacity and more user throughput compared to the LTE. Many people say it's 10 times capacity can get more in 5G, and 10 to 100 times user capacity we can get in 5G. The second one is intelligent network. These days we can see the very fast growth in the speed of CPU and GPU, and combined with the super network, all the information can be gathered. And some of the information should deliver frequently to the user can locate it in the edge. So all this centered and distributed concept can be called a cloud network. So with this kind of cloud network, and as Glenn mentioned, low latency can make this kind of intelligent network. And third one is convergent network. So 10 to 100 times of devices can connect it with the name of IoT. So with this kind of environment, multi-radio technology can be used. So each user doesn't know which network is now using for. So in this era, I think unlicensed band or D2D connection can be important.
Ken, you want to add?
It's interesting. There's two perspectives. There's the user perspective, us running around with our smartphones, and what we're going to look for, and what the industry is going to look for. The typical user is looking for peak data rates, right? When I click the button, how fast does my video show up on the screen? That has a lot to do in the future with both capacity, speed, and as Glenn mentioned, latency. Latency is a big enemy to the responsiveness of the buttons on your screen. And so in addition to the peak data rates that everyone's looking for, right when you run speed tests, how fast is it? Although that's important, and also the latency issues become a big deal because with that many devices running in the network, or as Glenn mentioned, the ping time, the latency, that's going to play a big part in the responsiveness in the applications. I think what people are going to be looking for are, I would say, fiber-like speeds, right? With the wireline network guys trying to get fiber to the home, and the wireless guys trying to get essentially fiber to the phone, if you will, right? Fiber-like speeds, what that means is that the 5G infrastructure is going to be, in the tens of gigs, in the terabyte range. And so the infrastructure requirements that go along with 5G are pretty tremendous. But my view of 5G is really, it's more than just the peak data rate that the average user is looking for. It's the overall responsiveness of the network. The machine-to-machine part is huge. The devices are no longer just smartphones, they're cars, they're cameras, they're everything that's out there. Those devices are all going to be pinging that network, and the multiplication effect of those machine-to-machine devices is going to be tremendous, faster than we've ever seen in the past.
So Glenn mentioned that part of what could be defined by 5G or as 5G is going to be based around what kinds of use cases it's going to enable. And I'm hearing from the panelists that the Internet of Things, or machine-to-machine, however you want to call it, is going to be one of the big pieces of that. So starting with you, Ken, talk a little bit about the M2M piece of 5G, but beyond that, what other kind of use cases or new industries even do you think 5G is going to enable?
Well, certainly the one that's very hot on everyone's topic is the automotive industry. Enabling the smart grid of, for cars, for more efficient transportation is going to be very, very important. I believe that devices are going to be more connected to each other and develop quicker real-time data. And that's really what it's all about. More devices talking to each other, feeding that information back, and giving the end users more information faster. The automotive industry is one. I think any type of appliance that we touch on a daily basis is going to be connected. Not necessarily the mixer that goes in your kitchen, but I mean the bigger things are going to be much more connected, and not necessarily even just Wi-Fi. We're going to have 5G type infrastructure enablement in there.
Sungho, do you want to add anything?
I think video traffic is dominant. Currently, the dominant traffic is video. I think this trend can be maintained in the 5G as well. So one of the main sources of the high bandwidth of 5G will be video traffic. So currently we have HD video services in a 4G, but in a 5G, ultra dense, ultra high definition video can be provided by 5G network. So with this kind of ultra high definition, what can we do? So we think about immersive communication, for example, remote clinic or remote hospitality or hospital, or video conference call with high definition. And the second thing is low latency. In the 4G, we have quite good latency performance, but it's not enough to have the game or remote control. So a low latency feature in the 5G, we easily see some augmented reality or smart car, as Ken mentioned, and that kind of the use cases can be seen, I think. And third one is big data. So with the IoT, we will see the many and huge data from the devices. So we need to solve how to collect the data and how to analyze the data and how can we use efficiently that analyzed data. So that kind of things that we should look at carefully, and we can see the new businesses in that category, I think.
Want anything, Glenn?
Yeah, well, you had mentioned the Internet of Things, and I just wanted to expand on that a little bit. The Internet of Things it will involve use cases and businesses that we really can't even contemplate today, but there's some that we can contemplate today that you can see how we might be able to use a new technology like 5G to complement the networks that already exist. I'll give you one example. GE is investing, General Electric's investing heavily in their industrial internet. And when these big, multi-$100 billion companies turn their attention to something and start to invest heavily in it, you get a glimpse of where the industry is going. I'll just give you one example that GE has talked about publicly, wind turbines. They have sensors in wind turbines, and they want to be able to extract information off the wind turbine every 40 milliseconds. That information gets extracted, gets cached, gets sent up to the cloud, gets analyzed, gets downloaded back to the sensor in the wind turbine to provide real-time reorientation of the wind turbine to maximize the energy output. So that's one use case. And now that we've discussed that one use case, you can probably think of 1,000 other use cases. John Deere wants to use similar sensors in their combines to provide real-time, farmer-free orientation of its combines as it's taking the grain off the fields. Again, using data analytics to capture the information, send it up to the cloud, analyze it, send it back so that they can optimize the crop yield. So there's many, many of these industrial use cases that are going to be applied to what we now call the Internet of Things. And they'll grow. And as individuals in garages come up with new use cases, we're going to find very innovative ways of making use of this new technology. Smart buildings, smart cities. It's all about a dramatic increase in the number of connected devices. And so one of the problems that we are going to be trying to solve in 5G is how to connect that tremendous crescendo of devices that will be coming onto the network, being able to maintain the two-way communication to those devices, extract information off of those devices or sensors and do the analytics. One last point. You've mentioned METIS, the European organization that is helping define the use cases that we're going to be tackling with 5G. For the first time, in the development of an air interface standard, we have a major industrial partner, BMW, who is sitting on the METIS board, back to the connected car point. And so these industrial use cases, I think, are going to be one of the key drivers of the next generation of air interface.
So, right on that point, you mentioned there are a lot of things that we can't contemplate. One of the things that we probably have a better idea of contemplating is that question about the air interface. And as somebody who works for a company that is heavily involved in the radio access network, do you anticipate, Glenn, that 5G is going to involve a whole new air interface? We have a lot of carriers and a lot of vendors who have sunk a lot of money into building LTE networks and working with that standard. Do you think that we're going to have to develop a whole new standard, or do you think that it's going to continue to use LTE?
That's a great question, and I think we would say it's uncertain at this point. It's clear that there is a lot of extensibility to LTE, and we're now talking about all of the ways in which we can continue to extend and by extension increase the spectral efficiency, squeeze more bits per hertz out of LTE. LTE Advanced is really just the beginning of what we can do. Bundling 2-3 carriers together to get wider bandwidth, more and more innovative interference cancellation techniques to increase the capacity of LTE, and more innovative and aggressive use of multiple antennas to increase the spectral efficiency of LTE. So LTE has got tremendous extensibility, and under any circumstances, any contemplation of 5G is either a clever combination of the air interfaces that already exist, or perhaps a new radio to deal with specific use cases that we just can't get to as efficiently with the existing air interfaces. But I think that's to be decided. I think we're a long ways away from determining whether it is actually a new radio or not.
So there's obviously a lot that's undecided at this point. One of the things that I think the industry is coalescing around is this idea that 5G networks are going to start being commercialized around the year 2020. It's not, a hard and fast date, but certainly plenty of organizations and plenty of companies have set that as a target date for when they want to start, putting commercial 5G networks into the market. So, Sungho, what do you think, operators, vendors, the entire industry needs to do, or should have as their goals in terms of getting networks ready, between now and 2020 to make this transition?
Sorry. That's a good question. Actually, good question and difficult question, because we don't have a clear definition of 5G. So it's very hard to say what is the goal of the specific goal of the industry. But I would like to say, definitely we need more discussion and more consensus before setting up the goal. But I can say for the infrastructure vendor and system vendor, we need to prepare small cell and advanced antenna technology. Usually the advanced antenna technology like active antenna system is openly mentioned in the macro cell, but I'd like to say we have put effort to integrate small cell with advanced antenna technology. Why? In order to get high throughput, much more high throughput in a 5G, we need to densify along with advanced antenna technology. Both can, those guys cannot separate it. So in the infrastructure and system vendor, prepare small cell combined with advanced antenna technology. And for the device vendor, I think we need to find clearly how to use multi-antenna technology. In the 4G, in the specification, we have 8 antenna, but we couldn't use 8 antenna well because of the limitation of devices. So we need to find how to put uncorrelated antenna in the small device. And the other thing is RF technology. In the carrier aggregation, even with the 2 carriers, we have several combinations of the frequency band. So in the devices, we need to find a way how to support several combinations of the RF signal. So that kind of trend can be more serious with a 3 carrier, 4 carrier, 5 carriers. So we need to find the RF technology for that.
Ken, you want to add anything to that?
Yeah, absolutely. Look, we all know, 4G and LTE's got I agree with Glenn. It's got a long runway, right? LTE's got a long way to go in the growth, succession of different versions. It's about density. It's about the cable infrastructure. There's no doubt there's going to be new air interface. There's going to be new waveforms. We're going to go down in frequency, up in frequency, right? But the reality is, what 5G will represent is a massive restructuring of how we view our infrastructure. I kind of liken it to bridges in the United States. You know, we have over 60,000 bridges in the U.S. that require maintenance and repair and expansion. And if we don't, what will happen? We have economic problems that result from our cities not being able to be connected. It's very similar in our industry. If we don't build the right bridges, the right pipes, the right infrastructure, and it doesn't just mean optical, just because you know, Solid's an optical company, but it requires all types of connections and bridges to connect all these devices, all the infrastructure in there. So, you know, building that core infrastructure in the United States is going to be key. And it's, you know, LTE overlays, we added pipes, we added infrastructure, but for the most part, we did a lot of what we already had. We expanded what we already had. So there's going to be, I believe, a new dawn. With 5G, there's going to be a new dawn of growth that's required in order to achieve those levels of speeds. An investment in our infrastructure, an investment in our bridges.
So moving on to kind of how this is all going to change network design. I think all three of you have mentioned multiple times already this idea of, you know, as we move to 5G, the networks are just going to get more and more dense than they already are today in terms of small cells, in terms of you know, just the amount of infrastructure that's going to be needed to support these billions of connected devices. So, Glenn, when operators and infrastructure providers are thinking about this densification for the network, you know, how is that going to affect network planning in a way that's different than the way we think about planning networks today?
Yeah, basically network planning is going to increasingly turn to software, so the industry, infrastructure vendors, and operators are working very hard at self-organizing, self-optimizing networks, and increasingly the ability to use data coming off the network to inform us of how we can provide real-time adjustments to the RF network to move capacity where it's needed dynamically is going to become increasingly important. So we would literally have the ability to move capacity to wherever in the network, in a stadium, for example, where there's about to be 80,000 people arriving for a football game, to be able to move capacity dynamically around the network to provide real-time performance improvements to the network. If you know, to make the most obvious example, a bad cell in the network or a bad sector in the network, we won't have to we won't have to use people to provide the performance improvement. Software will provide the performance improvement. And so I think we're going to see an increasing reliance on software for the self-organizing networks, self-optimizing networks, using data coming off the network to help with the RF planning of the network and to help with the real-time optimization of the network. So a significant increase in software to optimize networks I see as the big change well before we get to 5G. And in 5G, it would just become the necessary underpinning to 5G. A big part of what we're trying to do in the networks today is a more seamless connection between the core network, which is substantially moving to the cloud, to you know, virtualized network elements that sit in a data center, and the RAM. How much video caching do we have to move out to the RAM, for example? How can we move capacity around the RAM to meet the needs of our subscribers? And all of that is going to be done in software, and the more seamless integration of the core network that will sit in the data center and the RAM will be done in software.
So anybody want to tackle that question about network planning?
Yeah, I fully agree with Glenn, and we need more optimization using song in case of the small cell case. You know, in Korea, especially at KT, all of the operation is centralized. I mean, we have SON function, so centralized SON function can manage all the network. But in case of small cell era, the number of cells is huge. So one centralized SON cannot control all the cells. So I think we need to combine centralized concept with distributed SON concept. So when we turn on the small cell in some area, so the setup and the managing should be done by the distributed SON. In addition to that, I think we need more accurate planning when you deploy the small cell. So one of the concepts of the small cell, the location of the cell can be close to the user. That means we need more accurate, more appropriate deployment is needed. So I think we need some kind of new technology to get this fine deployment for the small cell. That means we're gonna use some minimized driving test function, or we can add some software enabled function to get some information of the actual real-time information combined with the position of the UE.
Ken, you want to add?
Yeah, absolutely. So I like to turn it a little bit different. So right now, we've been talking a lot about outdoor networks, essentially the macro networks. Being an in-building company, the focus on in-building is actually going to be critical to 5G in the future. It's critical to 4G already, as we can see. And it really is going to come down to scalability. So an in-building solution, regardless of what it is in the future, from 4G, 5G, that's where the users are. That's where the bulk of the video playing is going to be. I go to Korea all the time. I'm going to tell you, when you sit in the subway there is hundreds of people all on their devices, all at the same time, all streaming video live, all the time. That's what they do. And in the United States, I believe that's getting more and more popular as well, as people start being able to rely on the network, their data plans work with that. So that means that these buildings are going to have the bulk of the capacity, which means that building essentially becomes its own cell, and which means you need the infrastructure to support that cell, which is really going to drive scalability in the future. How are we going to build a network that can support backhauling all these massive cells or buildings with hundreds and hundreds of people in them, or thousands of people in them? How are we going to get that? How are we going to design a network around that? There's no doubt, we have the streets and the outdoor coverage we have to solve for. But when you really think about it, it's inside the buildings is where it's really going to be a big issue. The SON part even becomes more critical, because inside the building you have SON as well. If you're going to deploy devices in the ceilings for your capacity, your network, they're going to have to self-optimize. It's going to have to be much faster and easier.
Well, do you think that indoor deployments are going to be more difficult and complicated with 5G than they are with LTE?
Actually, I don't. I do believe that the technologies will actually help the in-building situation long term, because we're going to have much more sophisticated radio and software capabilities. Like Glenn mentioned, the software. That software will migrate its way into the in-building technology and allow for much more efficient designs in the building. Much akin to wherever you need it, you add it. Kind of like Wi-Fi, except I believe even more sophisticated than Wi-Fi, because it's going to be much more capable in terms of, at least from a 5G perspective, much more capable on the SON side. When you have more users in a room like this, you might just turn on 4 or 5 more devices, and they'll self-optimize. And that's ideally what the network operators need in order to handle that capacity. And from an outdoor perspective, I think we're going to see in 5G, we're going to see a lot more self-backhauling, more kind of the mesh topologies, where devices, the radios are going to be able to kind of reformulate their own network in order to solve some of their own backhaul problems and their own connection problems. And then I believe we're going to have, that's also going to lead us to dynamic spectral reforming. That's absolutely required and to make more efficient use of that spectrum that may be not even used in some parts of a city, and be able to refarm that and restructure on demand. Versus today, we fix it, we set it, and then if it doesn't get used, it doesn't get used, and that's just inefficient.
So you mentioned refarming, which brings me to my next kind of couple of questions, which is, you know, we're already seeing in the U.S. Carriers start to refarm their legacy spectrum for more advanced services, whether it's PCIA spectrum for LTE or, you know, just refarming in general. Excuse me. And I think that that is going to clearly accelerate over the next few years as data traffic increases. So kind of a pair of linked questions, and we'll start with Glenn, which is, you know, how quickly, you know, should operators be thinking about refarming legacy spectrum as we move toward 5G? And then, you know, something that I think we tend to gloss over in the industry when that happens is what happens to all of that legacy infrastructure? You know, does it get repurposed? Does it get junked? You know, because we're going to be adding even more infrastructure for 5G, and yet we have all this legacy infrastructure that's tied to, you know, different use cases, but that, you know, the spectrum that was tied to those services is being repurposed. So, you know, first, you know, address the spectrum question, if you could, and then, you know, thinking about that legacy infrastructure, what happens to it? You know, how should operators be thinking about that? I'm sure Sungho can address that from an operator's perspective as well. But why don't we start, you know, with you, Glenn?
Yeah.
Well, why don't we start with Glenn, and we'll go down.
Yeah. Okay. So let's start with the spectrum issue. I think there's probably no topic that operators spend more time on than considering how they're going to be deploying their very scarce resource. And you know, I think the way it's going to roll out in North America, I'll let the operators speak for themselves, but we've pretty much substantially completed the first channel of LTE. A few operators are well into the process of building out and turning up the second carrier of LTE, and then just now starting the plans of refarming the existing spectrum at 1900 megahertz and then 800 megahertz. And we see this happening gradually between now and the 2017, 2018 timeframe, where we're going to start to see some of the 2G network being turned down and the 4G network starting to replace what was in place in 3G. And we see it as a very gradual continuum. I think the difference in 5G is that the way we're thinking about 5G is it would more than likely be in a completely different area of the spectrum. So not a replacement for what is going to be going into the ground over the next 5 years, but additive to what is going to be going into the ground. To answer your question about what happens to the equipment that was installed in 1999 to, for example, turn on CDMA 1X RTT, that equipment will substantially be pulled out and replaced with an LTE channel card. The antennas have already gone through the process of being replaced and transitioned. And so that transition happens over a long 10-year time horizon. The transition from 4G to 5G will be less of a transition and more of a combination where we're now addressing some new use cases or new problems that we may need additional capability to help us address. But all of that LTE infrastructure that's going in today, we see being in there for a long time because it will be the foundation or the anchor of our wireless connectivity going forward.
Something you want to add from the operator's perspective?
I think in operator point of view, the answer is pretty simple, but real world, this issue is not simple. You know, operator wanted to refarm because we can get more benefit from the refarm or new technology. But legacy user, for example, 3G user, some people doesn't want to move to the 4G because they don't just want to use the voice and just use some simple web services. So we need intensive discussion when we're considering leaf farming. But in Korea, recently, as I mentioned, we launched LTA services with 2 carriers, and 1 month ago, we started refarm the 3G band to 4G. So probably we could see the 3 bands carrier in the next year. So this kinds of refarming is already happening from the 3G to the 4G, and then that kind of refarming also can be seen in 5G era.
So I think all of you have mentioned small cells in the context of 5G, and kind of want to ask this question to you, which is, a few years ago, I think that a lot of people thought that small cells were going to be this panacea for the network, and it was going to really kind of relieve capacity constraints. And I think that halo has kind of faded a little bit, and we now see small cells as important tools in the toolbox, but being used to sort of fill in capacity in specific highly dense areas. How do you think, as we transition to 5G, the use of small cells could change, from a deployment perspective or from just sort of what they're used for?
Well, I think small cells is the terms and the devices and what everything looks like has been debated quite a bit. But I think small cells are going to be absolutely revolutionary to our networks long term. By the time we hit 5G, I believe that the silicon technology, the baseband processing power of the devices are going to become much stronger. Our ability to deploy them faster, either on a fiber or in a mesh topology, are going to be much stronger. Using them from an in-building perspective is going to be critical. So I look at it differently than just saying, well, we're going from a 3G to 4G and it's a different little device that we use here. It really is an evolution of our entire network, both indoor and outdoor. And the devices will all increase in their capability, and we'll be able to use them much more efficiently in our outdoor and indoor networks. And ultimately, the goal is for them all to work together. So even though they kind of have the niche category called small cells, the reality is they're all going to be working together long term. By the time we hit 5G, these devices are going to be all talking the same.
I just want to stick with you, Ken, for a second, because we're talking about all this infrastructure that's going to be added to our buildings, to the landscape. How should the industry be thinking about the aesthetics of this? Everybody in this room knows how much of a fuss people put up when a new cell tower wants to new cell towers being put in their neighborhood. We're going to be adding lots of new antennas, lots of infrastructure. How should we be thinking about the aesthetics of this? I know it's kind of a tangential question, but I think that it's an important one as we get just more and more physical infrastructure in the ground on our buildings everywhere.
It's a huge problem. In the city, we typically call the equipment now, instead of just a box, it's street furniture, right? What does it look like? Does it blend in with the environment? It becomes a huge situation because now we have massive MIMO. By the time we get to 5G, you're going to have massive MIMO or multi-MIMO beyond what we see today in order to get that efficiency in the network design. You still have amplifiers, you have physics, you have an air interface. You got to get that signal out to the device. If you multiply that by 100 times, you need that power. You need RF power to get those devices. So ultimately, when we get to that point, smaller. Actually, I wrote it down here. So we have smaller, lighter, and stealth. Stealth is kind of overused. Aesthetics, I guess. Smaller and lighter are key. We only have so many poles, so many walls, so many places to put things. People are very sensitive. Hotels like this don't want to see anything on the ceiling or the wall. They want everything hidden. It's a huge challenge for infrastructure providers of all types because these things don't get small faster because we're also trying to add capability to them. So we're adding more capability to all of the infrastructure, yet it has to get smaller at the same time. So it's quite challenging. And then one of the things that we've been doing for quite a long time is in the networks, like in DAS or anything else, we add bands. So we add more bands, we have more protocols, right? So we have lots of bands. Ultimately, we need infrastructure that is a little bit smarter in the use of bands I would use the word maybe even cognitive. It has to be able to say, you know what, this device is over here, it's locking on to this band, and that radio can adapt to that frequency. Because we just can't deploy 8 amplifiers on a street pole anymore. It's just not efficient. It's not going to happen. And not only that, not only can we not deploy 8 amplifiers on a pole, but we can't supply 24 hours of battery backup on that pole either at the same time. So there's some limitations, to what we're going to be able to do.
So you mentioned the battery, and Glenn, I want to have you address this, which is one of the things that I'm hearing about how we're going to measure 5G networks is energy efficiency. These networks are going to become more energy efficient, and that's not only beneficial from a environmental perspective, but from a cost savings perspective as well. So how is this push towards greater energy efficiency in the networks going to change site design, network design?
Well, I think site design is going to be an area that is one of the key drivers of this basket of technologies that we'll call 5G. If you multiply the number of cells that are in the network by a factor of 100 or 1,000, because there's no question that small cells, very small cells, are undoubtedly going to be the way that we're going to be delivering the dramatic increase in demand. Small cells that are coordinated with the macro, because that's the key value that the network provides. Because the cells have to get smaller, the ergonomics of the cell is very, very important. And I think you're going to start to see a lot more innovative designs in the radio being integrated, the radio and antenna being integrated into the cityscape, integrated into light poles, integrated into the fabric of the cityscape. And because that is going to become a real use case for the network of the future, call it 4G plus or call it 5G, because that is going to be a real use case, the energy efficiency of the cells becomes increasingly important. And we're seeing a lot of investment now being plowed into the energy efficiency of the cells. So, exactly to the point of the complexity of putting 4 hours of battery backup on every macro cell that is consuming a significant amount of power. What we're seeing, just like we see in the data center, efficiency is measured now in terms of power utilization. We're going to see the same thing in the cell sites, measured much more with respect to the power utilization of the cell site. So we see ultra small cells being coordinated with the macro. We see a lot of investment going into the integration of these small cells into the cityscape, what we call zero site cells. So you can't actually see the cell if you're a pedestrian walking by, and high energy efficiency within the cell to dramatically reduce the power utilization and increase the uptime of that cell.
So last question for the panel, and then we're going to open the floor up to Q&A. Excuse me. And I'll start with Sungho, which is, for the people in this room, thinking about 5G and thinking about infrastructure and what they need to do to get ready in the next 5-6 years as we're moving towards this evolution. What would you say are the characteristics or the imperatives for infrastructure companies that want to benefit from this transition to 5G and want to be a part of it as operators move in that direction?
Actually, one of the things we should prepare for the 5G is we need to open interface. I mean, in the 4G, some of the interface is closed. That means one of two key players can dominate some economic of the industry. So things we are looking for in 5G, we need open interface, and we can gather a lot of good idea into together, and then we can boom up our industry, infrastructure and devices and all other industries. And the second thing is we should consider the software and IT. So since we already deployed VoLTE, that means in the 4G we already get all IP network, but in the next, what is the next? The next is all IP network. So we need to keep focus. We always thinking about the software is very important. And third one is I want to ask the industry to keep close relationship with operator and regulator, and then keep listening to which way we should go.
Yeah, I believe that what we need to focus on is not the old way we've done it. By the time we get to 5G, the way we've done it for the last 20 years plus is not going to work anymore. Both from building the infrastructure to building the equipment. I think what I want to see from the industry is a massive restructuring on the baseband side in terms of, we're talking about IP now, right? We're not talking about voice processing, voice switching anymore. We're talking about what amounts to massive server farms of computational baseband calculations to basically process all of this traffic. And that requires a lot of processors. It almost requires, dare I say, Google-like server farms, super central offices, if you will, to process all this. And so the wireline network is going to be very much a part of this. I believe we're going to see a revolution in the type of equipment that goes into the central office and different types of POPs in order to achieve this level of processing to handle all these devices. And that's where I think we're going to see a big revolution. There's no doubt we're going to see a lot of change in the actual amplifiers and antennas and all the technology that goes along with it. There's so many vendors that are going to have some amazing technologies released in order to support those things. But the core of the network is going to have to grow to support it all.
Glenn, you want to add?
No, I have nothing to add.
Okay. Well, with that, we're going to open the floor up to your questions. So Caitlin from PCIA has the mic, and feel free to just raise your hand, and we'll try to get to as many as we can in the time that we have left. So if you could please identify yourself when you ask your question, and then we'll try to answer it.
Okay, I'm Cássio from American Tower Brazil. I'd like to make a question to Mr. Moon. What was the impact on the operational costs when deploying the small cells, and how many small cells were deployed?
Small cell we have.
Yeah. Well, can you repeat the question?
What was the impact on the operational cost if compared to the macros network when you deploy the small cell?
Okay. That's a good question. Yeah, definitely I think we need more operational costs with a small cell because number of cells increased. So, but I think that's why we need to find a way for the SON, the better SON, combined with the C-SON and D-SON. So with this kind of technology, I think we can minimize the operational cost of the small cell.
Next question.
My name is Ernest Worthman. I'm the editor of AGL's Small Cell magazine. One thing that has popped up in my research a lot is how to deal with the security of the objects that will be out there, especially with the internet, the Internet of Things, M2M, autonomous objects. And Glenn, probably you would be the best one to answer this, you're a hardware guy. What is the present state of security of things for the Internet of Things, of everything?
That is a very good question, and that's a central issue. I think it's an issue that the wireless industry will need to get a hold of way before 5G. It's one that we need to start managing and managing very aggressively right now. Security, authentication, identity management is an issue that we as a wireless industry needs to own. And we have seen on the consumer side, Facebook essentially become the identity management vehicle of choice, which works very well on the consumer side. On the enterprise side, as enterprises are shifting their base of operations from the desktop to wireless, and we're starting to see, we're starting to be on the cusp of mission-critical applications moving to wireless communications and wireless computing. The thing that is standing in the way of that happening, of us moving forward aggressively with the future architecture that we know is going to be in place, which is applications move to the cloud, and those applications get delivered to mobile devices of all kinds. Salesforce.com, for example, on a mobile device, and all the mission-critical applications that line up behind that. CIOs of enterprises need to know that there is a security model in place that I can securely deliver that content to that device, that I know that the guy that is on that device is authenticated and has access, or should have access, to that information that I'm about to be sending. Security, identity management, authentication are critical issues for the industry to solve. And when we get to 5G, if we just sort of define 5G as being the 50 billion device world, the Internet of Things world, then the problem becomes 2 orders of magnitude more difficult to deal with than it is today. So we have to deal with those security issues today. I think it is a critical issue for the industry to solve.
Next question, anyone out there? Anybody?
Yeah, John Brandfeld with ADRF. Sungho, this may be a question for a different panel at a different conference, but you touched on antenna paths at one point. And I'm curious if there is concern or thought that the primary limiter to commercially viable 5G by 2020 won't be the ability to enhance the network, but it'll be the handset, the end user device. And is 5G going to account for the efficiencies needed for a battery to have any appreciable life without constant recharging?
I'd like to take a crack at that one. I come from the handset industry, and I got to tell you, the handset industry will move pretty fast, and it's always driven at the chipset level. So the chipset leaders, both large guys like Qualcomm and Intel, as well as small, very innovative companies, are already looking at techniques to address both the radio capability as well as the application processing capability that they need at the endpoints. And so I think that part of the industry will work in lockstep with the networking industry. I still see the bigger problem being on the networking side, because the intelligence in the endpoints is going to continue to double every 18 months, and there will be very highly capable devices in that time frame. What we see in that 2020 time frame, though, is take the 6 billion to 8 billion smartphones that we'll have that has that. We'll have that tremendous computing capability inside the smartphone, and then another 50 to 100 billion connected devices, which will be sensors, not all that intelligent, but streaming data to a network that will have to manage that data. So I actually still see the problem more on the network being able to keep up with the innovation that will be able to, or that will be naturally driven in the endpoints.
All right, we got one more question if anybody has a question out there.
Hi, this is Steve King from 3M. So I think this is addressed to Glenn. I'm really intrigued by the idea that you would have sort of an M-to-M overlay existing on the 5G. You could think of it as physically separate from the 4G network. It's handling all the data and the voice traffic. So my question is this: would you envision purpose-built small cells to handle the M-to-M traffic on the 5G network, because their physical location would be different from where the people are for the current small cell locations?
Yeah, I mean, I think it's a great question, and I don't think, I think that any answer that I would give would have to be ambiguous, because we don't know. I just want to go back to the opening comments that I made so that there's no confusion. I think that 5G could well be an amalgam of the technologies that already exist without there being the need for a new air interface or a new radio. But if there is a new air interface or a new radio, it's to take advantage of very high spectrum. So spectrum in the 3 to maybe 6+ gigahertz range, and therefore potentially a new radio to deal with that spectrum band. And if that's the case, then that new radio, if there is one, would have to operate very closely to the and communicate very directly to the LTE network that exists. The LTE network will be an anchor point. It will always be there. And we can do a lot of these machine-to-machine networks, and we are doing a lot of these machine-to-machine network applications today with LTE. And we see that LTE network will be used more and more for machine-to-machine type applications. There may be use cases that require some new capabilities that we can't get at by extending LTE, and that's what we would look to 5G to provide. Again, probably up spectrum, probably very low latency, probably very low energy.
Well, with that, we are going to wrap things up. I want to thank my panelists, Glenn Laxdal, Sungho Moon, and Ken Sandfeld. I want to thank PCIA, and I hope that you all have a great rest of the conference. Thank you very much.